Mountains that breathe fire and ash, reshaping landscapes in moments. Volcanoes are among nature's most powerful forces. From the ancient tragedy of Pompeii to modern disruptions of air travel, volcanoes remind us of their immense power. A volcano is an opening in the Earth's crust where molten rock, gases, and ash can escape from below the surface. This process begins deep within the Earth, where intense heat and pressure cause rock to melt and form magma. The magma accumulates in a magma chamber beneath the volcano. When the pressure becomes too great, the magma is forced through a vent, a narrow passage leading to the surface. Upon reaching the surface, the magma is called lava. The basic structure of a volcano includes the magma chamber, vent, and crater. The magma chamber is a reservoir of molten rock beneath the volcano. The vent is the conduit that connects the magma chamber to the surface. The crater is the bowl-shaped depression at the summit, formed by explosive eruptions or the collapse of the volcano's top. Moving on, let's look at the size of the Earth's dragon. Volcanoes come in various shapes and sizes, classified mainly by their structure and eruption style. The four primary types of volcanoes are shield volcanoes, composite volcanoes, cinder cone volcanoes, and lava domes. Shield volcanoes have broad, gentle slopes formed by the flow of low-viscosity lava that can travel long distances. These volcanoes, such as Mauna Loa in Hawaii, tend to have non-explosive eruptions, making them less dangerous compared to other types. Composite volcanoes, or stratovolcanoes, are characterized by their steep conical shapes and are built from multiple layers of hardened lava, tephra, pumice, and volcanic ash. These volcanoes, like Mount St. Helens in the United States, are known for their explosive eruptions, which can be highly destructive and dangerous. Cinder cone volcanoes are the smallest and simplest type, formed from particles and blobs of congealed lava ejected from a single vent. These eruptions result in a circular or oval cone with steep sides. An example is Paricutin in Mexico, which erupted in a farmer's field in 1943. Lava domes are formed by the slow eruption of viscous lava that piles up around the vent. This type of volcano creates a dome-shaped, steep-sided mound. Lava domes can grow over time and are often found on the flanks or within the craters of larger volcanoes, such as Mount St. Helens. Now that we have understood their sizes and shapes, let's take a look at how they actually became these fire and ash-breathing structures. There are two main types of volcanic eruptions: effusive and explosive. Effusive eruptions involve the steady flow of lava onto the ground. The lava is typically low in viscosity, allowing it to spread out in thin, broad layers. Shield volcanoes are known for this type of eruption, which tends to be less violent and less hazardous. Explosive eruptions, on the other hand, occur when gas and magma build up pressure within the volcano until they are released suddenly in a powerful explosion. These eruptions can eject ash, pumice, and volcanic gases high into the atmosphere. Stratovolcanoes are commonly associated with explosive eruptions, which can be extremely dangerous and destructive. Several factors can trigger volcanic eruptions. One common trigger is the injection of new magma into an already pressurized magma chamber. Earthquakes can also play a role by creating new pathways for magma to reach the surface. Additionally, the melting of ice on top of a volcano can reduce pressure on the magma chamber, potentially leading to an eruption. Understanding these triggers helps scientists predict eruptions and mitigate their impacts. Volcanic hazards pose significant risks to both human life and the environment. Key hazards include lava flows, ashfall, pyroclastic flows, volcanic gases, and lahars. Lava flows are streams of molten rock that pour from an erupting vent. Although they typically move slowly enough for people to evacuate, they can destroy everything in their path, including homes, roads, and vegetation. Ashfall occurs when volcanic ash, fine particles of rock and glass, is ejected into the atmosphere and settles over large areas. Ash can cause respiratory problems, contaminate water supplies, damage machinery, and collapse roofs under its weight. Pyroclastic flows are fast-moving currents of hot gas and volcanic matter that travel down the slopes of a volcano at high speeds. They are extremely dangerous due to their speed, high temperature, and the volume of material they carry, which can obliterate nearly everything in their path. Volcanic gases, such as sulfur dioxide, carbon dioxide, and hydrogen sulfide, are released during eruptions. These gases can be toxic and contribute to air pollution, acid rain, and respiratory problems. In some cases, large emissions of carbon dioxide from volcanic vents can lead to suffocation. Lahars are destructive mudflows composed of volcanic debris and water. They can occur during or after an eruption, when volcanic ash and debris mix with water from rainfall, melting ice, or rivers. Lahars can travel rapidly down river valleys, causing widespread damage and burying structures and landscapes under thick layers of mud and debris. Understanding these hazards is crucial for disaster preparedness and risk reduction in volcanic regions. Several volcanic eruptions throughout history have had significant impacts on human societies and the environment. Here are three of the most famous eruptions. Mount Vesuvius, 79 AD. Perhaps the most well-known eruption in history, Mount Vesuvius erupted catastrophically, burying the Roman cities of Pompeii and Herculaneum under meters of ash and pumice. The eruption killed thousands of people and preserved the cities in such a way that they provide valuable archaeological insights today. The suddenness of the eruption and the depth of the ashfall meant that daily life was frozen in time, offering a unique window into the past. Krakatoa, 1883. Located in Indonesia, the eruption of Krakatoa was one of the deadliest and most destructive volcanic events in recorded history. The eruption generated massive tsunamis with waves as high as 40 meters, which caused over 36,000 deaths. The explosion was heard as far away as Australia and the island of Rodrigues, near Mauritius, approximately 4,800 kilometers away. The eruption also had global climatic effects, causing temperatures to drop and leading to spectacular sunsets for several years. Mount St. Helens, 1980. In the United States, Mount St. Helens erupted with tremendous force, removing the top of the mountain and creating a massive crater. The eruption killed 57 people and caused extensive damage to the surrounding area, including the destruction of 250 homes, 47 bridges, and 185 miles of highway. The eruption was preceded by a series of earthquakes and steam venting episodes, providing a case study for volcanic monitoring and eruption prediction. When we look back at these famous eruptions, we might wonder if people could have predicted the disaster and the scale of destruction. Today, we have the technology to do so, allowing people to be prepared and manage the risks effectively. Predicting volcanic eruptions is a complex task that involves monitoring various signs of volcanic activity. Scientists use several methods to forecast eruptions, aiming to provide timely warnings to minimize the risk to human life and property. One primary method is seismology, which involves measuring earthquakes that often precede eruptions. Volcanic earthquakes are caused by magma moving towards the surface, creating fractures in the rock. By tracking the frequency and intensity of these quakes, scientists can infer that magma is on the move. Another key method is monitoring ground deformation. As magma accumulates, it can cause the ground above to swell. Using tools like GPS and INSAR, interferometric synthetic aperture radar, scientists can detect even minor changes in the volcano's shape, indicating that magma is rising. Gas emissions are also closely monitored. As magma nears the surface, it releases gases like sulfur dioxide. An increase in these gas emissions can signal that an eruption is imminent. Instruments placed around the volcano and aerial surveys help measure these gases. Despite advances in technology, predicting eruptions remains challenging. Volcanoes do not always show clear warning signs, and each volcano behaves differently. When they do erupt, they release large amounts of ash, gases, and lava, which can have both immediate and long-term effects. In the short term, volcanic ash can cover vast areas, damaging crops, buildings, and infrastructure. The ash can also pose health risks to humans and animals, causing respiratory problems and contaminating water supplies. Lava flows, though often slow-moving, can destroy everything in their path, including forests, homes, and roads. One of the most significant long-term effects of volcanic eruptions is their impact on the climate. Large eruptions can inject significant amounts of ash and sulfur dioxide into the stratosphere, where these particles can reflect sunlight away from the Earth, leading to temporary cooling of the planet's surface. This phenomenon, known as volcanic winter, can result in cooler temperatures and altered weather patterns for months or even years after the eruption. Historical examples, such as the eruption of Mount Tambora in 1815, have shown that volcanic activity can lead to global temperature drops and significant climatic changes. Human response to volcanic eruptions involves a combination of preparedness, monitoring, and emergency response to minimize loss of life and property damage. Preparedness includes educating communities about volcanic hazards, creating evacuation plans, and conducting regular drills. Authorities often establish exclusion zones around active volcanoes to keep people safe. Monitoring volcanoes is crucial for early warning systems. Scientists use various tools to track signs of impending eruptions, such as seismographs to detect earthquakes, GPS to monitor ground deformation, and gas sensors to measure volcanic emissions. These data help authorities issue timely warnings and coordinate evacuations. During an eruption, emergency response teams work to evacuate residents from danger zones and provide essential services, such as medical care, shelter, and food. Communication is key, with authorities using media, sirens, and social media to keep the public informed. After an eruption, recovery efforts focus on rebuilding infrastructure, restoring services, and helping affected communities return to normalcy. This can include clearing ash from roads, repairing homes, and providing financial assistance to those impacted. International cooperation and aid are often necessary, especially for large eruptions. Organizations like the United Nations and the Red Cross may provide support in the form of funds, supplies, and expertise to help manage the crisis and support recovery efforts. With their immense power, volcanoes remind us of nature's unpredictable and formidable forces. From ancient eruptions like Pompeii to modern ones like Mount St. Helens, they have shaped human history and the environment. Understanding their structure, eruption types, and potential hazards is crucial for our safety. As Bill McGuire once said, "Volcanoes are one of the Earth's most powerful and dangerous forces, yet they are also one of the most fascinating. They remind us of the dynamic and ever-changing nature of our planet." So, let's continue to study and monitor these powerful natural phenomena, so we can improve our ability to predict and respond to eruptions, ensuring safer communities and better preparedness for future volcanic activity. Thank you for watching. See you in the next video.